We're looking at solving radical equations, and there are four main steps to solving radical equations. One is to isolate the radical on one side of the equation. Next, we're going to square both sides. Then we're going to solve, which may require factoring. May require factoring. And then we're going to check for extraneous, extraneous, extraneous solutions, also known as make sure that the two numbers we check work, because sometimes we're going to get two numbers and only one of them works, so you have to check for extraneous solutions. So if we see 4 plus the square root of h plus 1 equals 14, we're going to solve for h. So first we need to get the square root isolated on one side, so we'll subtract by 4 and get the square root of h plus 1 equals 10. Now we're going to square both sides to get rid of that square root and get h plus 10 now equals 100. So when we subtract 1, we get that h equals 99. There we have it, h equals 99. Now we have the square root of c minus 3 minus 2 equals 4, so we start by adding 2. We get the square root of c minus 3 equals 6. Square both sides, we get c minus 3 equals 36. So now when we add 3 to both sides, we get c equals 39. Hopefully those have been pretty straightforward. Now, what gets a little tricky is when we get a variable inside and outside the square root. We have the square root of 2 minus y equals y. The radical is already isolated on one side. We have the square root of 2 minus y. So we'll square both sides. And now we have 2 minus y equals y squared. So now we need to solve for y. I'm going to move everything to one side of the equation and set it equal to 0. So I'll add y and subtract 2 and get that y squared plus y minus 2 equals 0. I could use the quadratic formula, I could use completing the square, I could use factoring to all these that I need to solve for y. I'm going to use factoring because what multiplies to negative 2 that adds to a positive 1? Well, 2 and negative 1. So if I say that y plus 2 and y minus 1 equals 0, then I get that y plus 2 equals 0, y minus 1 equals 0, so y equals negative 2, and y equals 1. Now, this is where I have to check for what's called extraneous solutions, or extraneous values as they are. Extraneous values. I have to plug in each solution and see if it works to the original equation. So, does the square root of 2 minus 1 equal 1? So does the square root of 1 equal 1? 1 does equal 1. There we go. Now, looking at the other one, does the square root of positive 2 minus negative 2 equal negative 2? So does the square root of 4 equal negative 2? The square root of 4 is 2, which doesn't equal negative 2. So we have that our only solution is y equals 1. Let's take a look at another example. X minus 3 equals the square root of x minus 1. The radical is all by itself, so we'll square both sides. Now, be careful here, because when we do x minus 3 squared, we really have x minus 3 times x minus 3 equals x minus 1. So we have to FOIL over here, foiling. So we're going to get that x squared minus 6x plus 9 equals x minus 1. I'm going to subtract this x and add this 1. So I get that x minus 7x plus 10 equals 0. Well, what multiplies to positive 10 that adds to negative 7? I get x minus 5 and x minus 2 equals 0. So x minus 5 equals 0, x minus 2 equals 0, x equals 5, and x equals 2. Let's plug in and see what we get. Oh, you can't see. We get x equals 5 and x equals 2. Let's start with 2, if we start with 2. So does 2 minus 3 equal the square root of 2 minus 1? So does negative 1 equal the square root of 1? Negative 1 in fact does not equal 1. Womp womp. Now if we take 5 minus 3, does that equal the square root of 5 minus 1? Does 2 equal the square root of 4? You bet it does. So therefore x equals 2 is our only valid solution. Please do something to indicate. One, first of all, show me that you checked for extraneous values. Two, show me something to indicate that that's the final solution. If you don't, if you write 2, that will not be correct because I don't know which one is your solution, and in this case we only have one solution. Our practice problems, we have page 1491, 9 through 20. Number 9 starts the square root of a plus 11 equals 21. So we get the radical by itself. So we have the square root of a equals 10. We square both sides. And easy enough, we get that a equals 100. Alright, so remember, we isolate the radical. We square both sides. We solve, which often involves either factoring or completing the square or the quadratic formula. We need to remember those 3 solving techniques. And then finally, if we get 2 solutions, we need to check for extraneous values. Alright, take your time. You can do it.